Good morning, class. Here's chapter 1, functions, section 1.2, domain and range. Chapter 1, function. We have covered functions and function notation. Domain and range will be covered today. And then we continue into more sections. The objectives are: find the domain of a function defined by an equation, graph piecewise defined functions. So that's what we are going to do. Could somebody read this for us? Benia, please.
Yes.
Please.
Recall functions and function notation, dependent and independent variables. For an equation in variables x and y, if the value of y depends on the value of x, then y is the dependent variable and x is the independent variable.
Go ahead.
Relation, a set of ordered pairs. Domain, the set of all input values, which are x values, the independent variable, for a relation. Range, the set of all output values, which are y values, the dependent variable, for a relation.
So here's a graph, and you need to understand domain simply means all the x values covered by the graph. So along the x, whereas the range is along the y, every y value covered by the graph. Please continue.
Function. A function is a relation in which each element in the domain corresponds to exactly one element in the range. Vertical line test. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph does not represent a function. If a vertical line cannot be drawn so that it intersects a graph at more than one point, then the graph represents a function. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. Horizontal line test. If a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not a one-to-one function.
Excellent. In short, when we are dealing with a function, x coordinates cannot repeat. When we deal with a one-to-one function, the y coordinates cannot repeat either. All right, here's the summary for library of functions. F of x equals b. This is a constant function like y equals b. It's a horizontal line. Domain is all real numbers. Range is just one point b. Identity function, y or f of x equals x, a line through the origin. domain and range, all real numbers. We need to know the graph of elementary or essential functions. These are some of those. Square function, f of x equals x squared or y equals x squared. It's a parabola. Domain is all real numbers. Range is 0 to infinity. Cube function, f of x equals x cubed. Looks like that, with the domain and range being all real numbers. Root functions, square root, f of x equals square root of x, looks like that. Domain and range from 0 to infinity. Cube root function looks like that. Domain and range, all real numbers. Reciprocal function, f of x equals 1 over x. It's a rational function which has a vertical and horizontal asymptote. Domain, all real numbers except 0. Range, the same thing. This is how we write it. Minus infinity to 0, union 0 to infinity, that would be the domain, as well as the range. One point two, domain and range. Francisco.
All right. Domain. The set of all input values, x values, independent variable for a relation. Range. The set of all output values, y values, dependent variable for a relation.
Excellent. So as you can see from this graph, if you try to lay it down along the x-axis, what does it cover? That's the domain. If you try to lay it along the y-axis, what does it cover? That's the range. Could you read the question, please?
Yeah. Example 1. The graph of a function f is shown. A. Find the values of f1 and f5.
We are interested in finding the functional values. F of 1. That means find the functional value when x is 1. So you locate x equals 1, and that's the point. This point has coordinates 1, 3, and therefore f of 1 is 3. For f of 5, locate number 5 along the x-axis. 1, 2, 3, 4, 5 is here. And this is the point which has the x equals 5 as its coordinate. We need to see the y coordinate for that. That point seems to be at 5, roughly negative 0.7. Therefore, f of 5 is about negative 0.7. What are the domain and range We try to lay it down along the x-axis. This is the domain from here to here, 0 to 7. Try to lay this down along the y-axis. And that gives you from here, -2, to here, +4. There are two ways of writing it. You can say y such that y is between -2, and for inclusively, or you write it in this fashion also. This one you could write x is between 0 and 7. Preston,
For the function f represented below, determine each of the following. A, what member of the range is paired with -2? B, domain of f. C, what member of domain is paired with 6? And D, the range of f.
excellent. The idea is to read and understand the graph. So -2 is the x coordinate. This is the point. The coordinates are -2, 3. So that would be the answer. Domain. If you were to lay it down along the x-axis, what portion of the x-axis will this graph cover? Anywhere from -5 to +3. That's the domain. Part C. This is the y coordinate. So the y coordinate of 6. You try to read the x, doesn't have to be exact. It's roughly 2.5. The range, if you were to lay this down along the y-axis, it will cover from here to here, from -1 to +7. That's reading the graph.
Would you like me to start reading?
I think we did this question, didn't we? Yeah. For some reason, it's being repeated. That's fine. We are going to move on. Go ahead. Please read this one.
Finding the domain of a function defined by an equation. Start with the domain as the set of real numbers. If the equation has a denominator, exclude any numbers that give a 0 denominator. If the equation has a radical of even index, exclude any numbers that cause the expression inside the radical to be negative.
So excellent. Here's the warm-up example. So what you heard is the process by which you find the domain. G of x equals x squared minus 9. There is nothing to be excluded because it's a polynomial. And the domain is all real numbers. Same thing for part B, because in part B, the index is odd. When the index is odd, there is no restriction class. When it's even, it's a different story. In other words, this case. Polynomial functions. Could you read that, please?
A of n is not equal to 0. N is a, oh. N is a whole number, W equals 0, 1, 2, and so on. A of 0, A of 1, A of 2, all the way up to A of n, the leading coefficient, are constants called the coefficients of the polynomial domain negative infinity to positive infinity.
Excellent. So, class, polynomial functions are in the form of a sub n x to the power of n, and n is the degree, the coefficient, and it goes down all the way to the constant a sub 0. Okay? The exponents must be whole numbers. W stands for the whole numbers. And when that happens, the domain is all real numbers. For example, this is a polynomial of degree 2. We call it the quadratic function. We want to find the domain, and we follow the instruction of the previous page. You have a rational function. You factor the denominator and you set it equal to 0. You want two numbers, so this has to be factored out. You want two numbers, the product is -3, the sum is -2. So if x is 3, this becomes 0. If x is -1, this becomes 0. So you exclude those. One way to write it, x such that x is not 3, x is not -1. A better method is the interval notation as follows. Negative infinity to -1, union -1 to 3, union 3 to infinity. We are excluding the endpoints using parentheses because it makes it an open interval. G of x is square root of 3 minus 2x. When we don't have an index, the index is 2. So 3 minus 2x greater than or equal to 0. 3/2 larger than or equal to x, or x less than or equal to 3/2. This is the inequality format. This is the interval format. Now, we have a combination of a rational function and a square root. On the one hand, this must be greater than or equal to 0. And on the other, x can't be 4. Now, if we had this one only, this would be the answer, which is not. We also have this one. Is if 4 is not in between, this is done. Because 4 is in between, you write it in this fashion to exclude the 4. Again, if we didn't have this, this would be the answer. Since we have it, this is the answer. Given this function f of x is x over x plus 1, is this point 1 comma 1/2 on the graph of the function f? All you have to do, plug in 1. Since we got 1/2, the answer is yes. If you get any other number, the answer is no. X equals 2. Find f of x. Plug in 2. That gives you 2/3. What point or pair 2, 2/3? F of x is 2. Find x. So set this equal to 2 and solve. Cross product. 2 times x plus 1 equals x. 2x plus 2 is x. X is negative 2. Here's the pair. Graph piecewise defined functions. Sketch the graph of f of x equals 2x minus 3 times absolute value of x. Why is this a piecewise defined function? Is because of this. Recall. Absolute value of x represents distance from 0. So it's x if x is greater than or equal to 0. It's the opposite of x, minus x if x is less than 0. it's important for everybody to know this doesn't mean negative value. Actually, minus x is a positive value. So if x is greater than or equal to 0, we drop the absolute value. We get 2x minus 3x. If x is less than 0, we get 2x minus 3 and replace it with minus x. So again, look at this one. Okay, everybody. If x is greater than or equal to 0, absolute value of x becomes just x. If it's less than 0, absolute value becomes minus x. So this is what? 2x minus 3x, negative x, 2x plus 3x, 5x. So we have two different lines. And in fact, line segments. So if you ignore that you have two pieces, one of them is y equals minus x, which is this line. One of them is y equals 5x, which is like this line. And then we pay attention to this. So the way I want you to see is this. This one, again, don't pay any attention to the restriction yet. What is this line? The top one. Y equals minus x. What is this line? And I hope you know that 0, 0, 1, 1, and so forth, right? 1. You can even put, for example, 0, 0, 1, 1, and graph it. The next line is y equals 5x. And the same thing to graph this 0, 0, 1, 5. So you need a couple of pairs. So we graph it. And that's not the answer to the question. I just wanted you to see how easy these two started. Now, let's pay attention to the restriction. The restriction says f of x is minus x if x is larger than 0. In other words, this is only true if x is larger than 0. So this part is out. Okay, now I'm paying attention to this restriction. This one says y equals 5x if x is less than 0. So that means this part is out. So it will look like this. Okay. So the graph is what you see here. This is how you do the piecewise defined function. We will look at more examples. Example 6. Can somebody read it, please?
Yeah, I can read it.
Please.
Sketch the graph of the function f of x. Evaluate a few points and determine the domain and range.
Perfect. Okay, class. Let's first discuss a few points, and I want to show you how to graph this easily. This function is minus x plus 1 if x is between these two numbers. it's 2. That means really 1 point when x is 1. I hope you recognize this one as a pair 1, comma 2. And then it's this function if x is larger than 1. So let's look at, for example, just to figure this out. Let's pick up a few numbers. If it's negative 1, this says when x is negative 1, we have to go here. You have to use this one. If I put negative 1 here, I get positive 1, and 1, I get 2 here. 0. Since this is between negative 1 and 1, 0 goes here too. I get 1. 1 at x equals 1, we have 2. 1 gives you 2. 2, when x is larger than 1, you have to use this 4, 3, 9. So I hope you see how we get those pairs. Now, if you plot those pairs, you can graph it. But let's do this one by one. The top part, y equals minus x plus 1. And I have 2 pairs, 0, 1, 1, 0. 0, 1, 1, 0. And that's the line. Again, I'm going to do the restriction at the end. So you would, the way I approach it, I graph it without paying any attention to that. Next, f of x is 2 when x is 1. This is one pair, 1, comma 2. The point 1, comma 2. Last, f of x equals x squared is a parabola. Okay, now let's go pay attention to the restriction. This line is good from negative 1 to positive 1. So from negative 1 to positive 1. This is the portion. Negative 1, we have the equality, so this point is included. 1, you don't have the equality, there is a hole. 2, 1, that's that point, so we are good to go. Y equals x squared is good when x is larger than 1. So x is 1, located this point, has a hole, and everything at top is okay. This, why is there a hole here? Because we don't have the equality. And then everything at top. Put those together. Here's the graph. I highly recommend you graph them one by one so you see what happens. So what is the domain? I hope you recognize along the x-axis, it starts with this point, negative 1. Everything is covered all the way to infinity. So that would be the domain. The range starts from here and goes up, but this point is not covered because this is a hole. So it's not a bracket, it's parentheses. So why is this a parentheses? Because this point is not covered, but everything at top is covered. Find h of a minus 5. I want to look at a very simple example. where h of x is this defined as such. So you have to locate the -5 here. This is for x larger than -4. This is for x less than -4. So you have to use this one. So you put the -5 here. Minus, put the -5 plus for this. -1. This makes it positive. So perhaps even before that, we can write h of -5 equals. This is one notation I want to show you. When you have a piecewise defined function, you can represent it in this format and then finish the job. This is telling your reader which piece you are choosing. We want to graph this and find its domain and range. Remember what we do. We don't pay any attention to this stuff. We graph. So we're going to graph this function y, or f of x is absolute value of x, which is a V shape. So absolute value of x, and if you go back to the previous section, I've gone over that. It's a V shape. Again, we are not paying any attention to this one yet. Cube root of x. Again, this is an elementary function you should know. This is an elementary function you should know. We are not paying any attention to the restriction yet. So this is the absolute value function. Now let's put them together. How do we put them together? This one says from -3 to 1. So you locate -3 and you have a solid point. You go all the way to the 1 and you have a hole. Why a hole? Because it's inequality. And by the way, if you put them on the same set of axes that looks like that, okay? Now, this is the portion from the top. And this one is good when x is greater than or equal to 1. So you locate 1 from here, and that's equality, so solid point all the way up to the right. So now you put this point and this part together. By the way, this solid point will cover this hole. It looks like this. Put these two together. And so what is the domain? The domain starts from here, here, -3, and goes all the way to infinity. The range starts from here all the way to infinity. And of course, this point, this solid point, is included. This is how you draw piecewise defined functions. Graph the following piecewise defined function. F of x is 3 if x is less than or equal to 0 and minus x if x is between 0 and 1. Okay, so this one, y equals 3, is a horizontal line. You should know the graph of horizontal lines versus vertical lines. Y equals minus x, we've done it many times by now, you should be fine with that. So this is the graph of y equals minus x. Now, let's go to the restriction. This one, when x is less than or equal to 0, so less than or equal to 0, because it has an equality, you put a solid point here all the way to the left. Okay. This one starts from 0 and goes to 1, but 0 doesn't have equality. So you have a hole here and it goes to 1 to here. So this and this one looking like that. So again, a quick recap. Don't pay any attention to the restriction. Graph each piece. Use the restriction to come up with the answer. It's the last question and it's very interesting. This is a sinusoidal function class. Obtain info about the graph. Part A, f of 0, meaning x is 0, what is y? 4. Domain and range. So domain, lay it down along the x-axis. It covers from 0 to 4 pi. Lay it down along the y-axis. Covers from -4 to +4. Again, I'm showing you both ways of writing it. Not that you have to write both ways. Intercepts. Obviously, there is a y-intercept of 0, 4. And then we have this one, pi over 2, 0. This one, 3 pi over 2, 0. This one, 5 pi over 2, 0. This one, 7 pi over 2, 0. How often the graph intersects the line y equals 2? Draw the line. 1, 2, 3, 4. F of x is -4. What is x? So look for -4. This point, x is pi. This point, x is 3 pi. F of x larger than 0. What is x? In other words, where is the function above the x-axis? So as you look at this graph, this portion is above the x-axis from 0 to pi over 2. This portion, so union 3 pi over 2 to 5 pi over 2 is above the x-axis. This portion to let me actually do this. This portion so we write it in this fashion. 0 pi over 2 union 3 pi over 2 comma 5 pi over 2 union 7 pi over 2 to 4 pi.